Today we're learning about linear quadratic systems. So basically this is a really fancy way of saying we're going to learn how to find the point or points of intersection between a parabola and a line. That's all we're really doing. So before we actually get to the note, how about you think about how can a parabola and a line intersect? Do they always intersect? How many times do they intersect? So you might want to draw around and see what the possible answers are. So somewhere you might use this is, let's say you have, I don't know, a bridge that looks like this. Here's your fun little bridge there. And you are shooting a gun from here. Not very pacifist, is it? And you want to know where it's going to hit the bridge. Okay? So you're shooting an arrow, let's say, in a straight line, and you want to know where it's going to hit this parabola. So in order to do this, you're going to need an equation for the parabola and an equation for the straight line. And remember, how do you find an point of intersection between two lines? You just find, you set the two lines equal to each other because you're finding the points that are common. So you're going to set the equation for the parabola, the equation for the line equal to each other, and then we're just going to solve that equation. Okay? So that's what we're learning about today. So we're going to solve problems involving the intersection of a linear function and a quadratic function using graphs and algebra. So there are three different possibilities for how the graphs can intersect. Okay, so hopefully you came up with that already in your head or you played around a little bit. So either there can be two solutions like this picture. So that means actually there's 2 points of intersection. You're going to get two x values. Or there can be just one solution. Okay, it just hits the parabola one time exactly. Or there can actually be no solutions. They might not intersect at all. So take some time to draw these diagrams so you understand why there are three possibilities for how a graph of a parabola and a line can intersect. So here are the steps basically of how you're going to answer these problems. So you might want to have these steps available as you're doing your homework. They're helpful as you're learning the process, but of course you won't have this with you on a test or exam, so you should gradually get away from having to refer to these steps every time. But definitely as you're learning until you're confident, have these steps right with you as you're doing the homework until you start feeling good and successful at what you're doing. So you're going to have an equation that's a quadratic, and you're going to have an equation that is a line. So you're going to first make sure that they're in the most useful form. So standard form for a quadratic and y equals mx plus b form. So that could be something like y equals 2x squared minus 3x plus 7. And then your line would be something like 3x minus 4. Okay? I'm just making those up. So if it is in vertex form, make sure you convert it to this form, or factored form, this should be in this form. Same thing here. Okay? Now remember, if you're given the picture of a line, you can come up with the equation by just finding what the slope is and what the y-intercept is. Okay? Then, to find points of intersection, you set these two equal to each other. So in this case, it would be 2x squared minus 3x plus 7 equals 3x minus 4. Okay? So now you're finding the x values for which this equation is the same as this equation. That should make sense to you. Now to solve something like this though, you can't just put all the x's on one side and the numbers on the other because we have x squared and just single x's. So we have to put everything over to one side so it's in this form. Okay? That's how you solve an equation like this. You have to move everything over. So this 2x squared just stays 2x squared. Then this 3x you have to subtract over here, so you get minus 6x. and then you're adding the 4 to move it over, so plus 11 equals 0. You have to make sure that you include the equals 0 to show that this is still an equation that you're solving. You can't just leave it without an equal sign. Now you solve for x. Okay, think about it. How do you solve for x from here? You have two options. Either you can factor, or you can use quadratic formula. Okay? So in this case, no easy factoring comes to mind, so I would go right to quadratic formula. But if I could see a factoring solution right away, I would just go to factoring. Really, it's up to you because either should work. You always need to know how to use quadratic formula because sometimes you're not able to factor. And then you can solve, if you need your y values, which you don't always need, but if you do need them, once you have your 1, 2, or 2x values, you can put them back into either of these equations. Linear one's easier, obviously, and find the y value that corresponds to that x value. So there you have it. So let's actually put this into practice. Now we have 3 examples. Now, it might also ask you to find the number of zeros, or the number of solutions rather, instead of actually finding what the solution is. So you can find just the number of solutions, or how many points of intersection there are, by finding the discriminant of the rearranged formula. Okay? And so that will tell you how many solutions there are. But remember that in a real life situation, even if there are 2 solutions, only one of them might be admissible. So if you have something with time, for instance, a negative response, you wouldn't include that. So you have to think about what makes sense within the scenario. Now, example 1 is, it's not a real life situation, so we're going to take any answer that they give us. So we have a quadratic and a linear function. It wants us to find out how many times they intersect, and then also find out where they intersect. So remember, step 1 is to put them into the appropriate form, but they already are, so that's good, that's done. So the next step is to set them equal to each other. So minus 0.48x squared plus 4.8x, there's no c value, so you just leave it, equals 0.24x plus 7.2. Okay? So then you can just rearrange and move things over, okay? You might want to pause the video and try that on your own. Make sure you get the same thing I do. But you get minus 0.48x squared plus 4.56, x minus 7.2 equals 0. Remember that equals 0. Okay, so the first question is asking you to use the discriminant. So basically, you need to use b squared minus 4ac. And if it's greater than 0, 2 answers, equals 0, 1 answer, less than 0, no answers, no solutions. So as you can see, when you put this in, 4.56 squared minus 4 times negative 0.48 times negative 7.2. If you do that, you'll see that it is greater than 0, and therefore there's 2 solutions. Okay, so that's part A. But part B actually wants us to find the points of intersection. So now we have to go to this equation, which is the rearranged one, and use quadratic formula in order to find the solutions. So remember, x equals negative b, so negative 4.56, plus or minus the square root of b squared, minus 4 times a. Now a has to be minus 0.48. You have to be very careful there. And then c is minus 7.2. All right? All over 2a. So 2 times negative 0.48. Okay, so quadratic formula is extremely useful, but it's only as useful as your calculator skills are good. So you have to be good at putting this into the calculator appropriately so that you get the right answers. Some people try to do the whole thing at once, and often they make mistakes. What I recommend doing in your calculator is first just determining what's underneath this square root. Okay, so putting in your calculator 4.56 squared minus 4 times minus 0.48 times minus 7.2. So then that should give you minus 4.56 plus or minus the square root of 6.9696 all over negative 0.96. Okay, you can also do this quick multiplication there. So this is much easier to put in your calculator to find the two solutions. Okay, so I really recommend that you do that just to avoid human error when you're using your calculator. Okay, so from here you get x equals 2 or x equals 7.5. Okay, so those are the 2 points of intersection, the two x values. Then to find the y values, I can put this into either f at x or g at x. So if I put 2 into g at 2 equals 7.68. And g at 7.5 equals 9. So again, I'm just putting those x values into this equation. And so you have your 2 points of intersection. So 2, 7.68 and 7.5, 9 are your 2 points of intersection. Okay, so you might want to go through this again. This is just the most basic example. You'll definitely be asked to do this on a test or exam. So make sure that you thoroughly understand this example so that you're able to do the practice as well on the next page and be successful in the homework. We really just went through the steps that we listed on the front page to solve this problem. So again, use those steps as much as you need to, but then try to get to the point where you don't need to read the steps every time. It just kind of becomes second nature to you. Okay, example 2 gives us the type of example that kind of drives some students crazy because it doesn't have any application to real life. Okay, this is more like a puzzle. It's stretching your brain a little bit, your critical thinking skills, your problem solving skills, your creativity, to say, can you take what you know, the different techniques that you understand, and can you apply it to a question that's worded a little bit differently? That's what this is asking you to do here. So sometimes these types of questions right off the bat, they seem really confusing. You're like, where do I start? So if you're not sure where to start, the best thing is to write down all the information as clearly and as organized as you can. So a line with slope 4 has only one point of intersection with this parabola, okay? And it wants to know what's the y-intercept of the line. So well, first, let's just think about this line here. It has a slope of 4, so its equation is 4x plus b, and it's b that we're trying to find, okay? It's the y-intercept we're trying to find, and we know the slope is 4. So that's the equation of our line, but that's what we want. Okay, the parabola and if you don't like this half, you can make it a 0.5. It doesn't really matter to me. But its equation is a half x squared plus 2x minus 8. Okay, and it's saying that this line only intersects this parabola once. So that has to do with the number of zeros. Okay, the number of zeros equals 1. So what do we have in our toolbox that tells us when the number of zeros is 1? Well, think about that. That's the discriminant. That means that the discriminant, b squared minus 4ac, has to equal 0. Okay? Does that mean the discriminant of this? No. It means that when we set these two equal to each other and then rearrange the formula, that discriminant will have to equal 0. So now it's just a matter of doing that. We're going to have b there, an unknown, and we'll be able to solve for it because we have this equation, okay? So if you don't quite understand yet, just take a watch. So half x squared plus 2x minus 8 equals 4x plus b, okay? So we're setting up their intersection. So if we were actually going to solve this intersection, we would move the 4x over here, so it would be minus 2x, and it would be minus 8 minus b. All right, because to get this plus b on this side, we would have to subtract b. Okay, so this means that our a value is equal to a half, our b value is equal to minus 2, But our C value, here's where it gets a little bit confusing, is equal to minus 8 minus B, because that minus B is part of the constant here. We just don't know what it is. That's what we're trying to solve for. So our C value is negative 8 minus B. So now that we've identified A, B, and C, we can put those into this equation of the discriminant equaling 0, which again tells us that the number of zeros is 1, which is what the what the problem gave us, and then we'll be able to solve for B. So B squared, so minus 2 squared, minus 4 times A, which is a half, times C, which is minus 8 minus B, equals 0. Okay, so notice that I put this in parentheses to make this a positive 4. Okay, you have to be careful with that. And then this becomes minus 4 times a half is minus 2 times negative 8 minus B equals 0. Okay, so let's just expand this. So minus 2 times negative 8 is plus 16. Minus 2 times minus B is plus 2B equals 0. So 4 plus 16 is 20. So 20 plus 2B equals 0. Okay, so we want to isolate B because we want to solve for B. So we get 2B equals negative 20. B equals negative 10. So there you go. So in order for this line to intersect this parabola only one time, this B value or the y-intercept has to be negative 10. You might want to think about now, how would answering this problem have changed if I had asked you, there are no points of intersection? Well, it only would have changed because instead of setting the discriminant equal to 0, you would have set it to make sure that it's less than 0. So in this case, your B would have to be less than negative 10. Okay, so you might see slight variations on this type of question, but anything where they're giving you how many point of intersections there are, you should think the discriminant. Okay, one final example. Something a bit more real life about Adam skydiving. Okay, so he has a free fall modeled by a parabola. So let's think about what this looks like. Okay, so this is his height over time. So this is the acceleration due to gravity, and then this plus 5,500, that has to be the y-intercept or the h-intercept. So that means that's how high he was when he actually jumped. So it's going to look something like this. Okay, there's his parabola, or this is 5,500. Okay, so that means that's how high he was when he jumped out of the airplane. Crazy person. Okay, and this next equation is what happens after the chute opens. So notice that its y-intercept is 4,500. And then it slopes down. So it's going to look something like this. And it's this point of intersection that we're looking for. Okay, so it's saying when should he open his chute? So obviously he wants to open his chute at the exact point so that when he gets into this equation, it'll drift him and so he nicely lands to the ground. We definitely don't want this situation, right? Going too quickly. So basically we have to say, when does this equation, the first one, equal the second equation? So we do minus 4.9 t squared plus 5,500 equals minus 5t plus 4,500. Okay, so I encourage you now to pause the video and try to solve this on your own, and then watch my example and make sure you did it properly. Okay, so first you rearrange everything so it's on the same side over here. So minus 4.9 t squared plus 5t plus 1,000 equals 0. Then you just use quadratic formula. Minus 5 plus or minus the square root of 5 squared minus 4 times minus 4.9 times 1,000 all over 2 times minus 4.9. Okay, if you do my trick that I suggest and find what's underneath the square root first, that should be 19,625 over minus minus 9.8. So you'll get t equals minus 13.78, which is inadmissible because time can't be negative. And you'll get t equals 14.81, okay, which is our answer. So notice that it just asks when he should open his chute. We don't need to know the height at which that occurs, so you're fine with just this solution. You don't need to go any further. So then you can just write a nice little therefore sentence. Therefore, Adam should open his chute after 14.81 seconds of free fall. And there you have it. That's linear quadratic systems. So I hope you enjoyed the video, and I hope you learned lots.